Welcome to The Explainer. Today, we're digging into a really surprising discovery about a fundamental limit in the AI that powers pretty much all modern search. And it turns out, just making these AI models bigger and throwing more data at them, well, that might not be the fix we all thought it was.
All right, so here's how we're going to break this down. First, we'll talk about the incredible promise of AI search, what we all want it to be. Then we'll peek under the hood at how it actually works. After that, things get interesting. We'll uncover a hidden crack in its very foundation, see how researchers proved it's really there, and finally explore what this all means for the future of how we find things.
You know, for years, we've been moving way beyond just typing in keywords. We've gotten used to the idea that our AI should understand not just words, but meaning, context, and sometimes incredibly complex and nuanced questions. I mean, we ask our search engines to handle some pretty complicated logic, like this, and this is a real-world example from a research dataset. We don't just want documents about moths, we're asking for documents about moths, or insects, or arthropods, but, and here's the kicker, only if they're also about Guadeloupe. That's a really high bar.
And so the dream, right, the big assumption in the tech world has been that if we just keep making the models bigger, keep feeding them more data, eventually they could learn to retrieve any possible set of documents for any query you could dream up, like a perfect librarian for the entire world's information.
So, how does this magic actually work? Well, the technology at the very heart of most modern AI search is this brilliant idea called vector search, and it's all powered by something called vector embeddings. Okay, think of it like this. The AI reads a piece of text, could be your question, could be a document, and it turns the meaning of that text into a set of coordinates. Then it plots that meaning as a single point on a giant multi-dimensional map. So things with similar meanings, like say, king and queen, they get placed really close together on this map.
And the actual search process is elegantly simple. Your question becomes, say, location X on this meaning map. Every single document in the library is also a point. And the AI's job is just to find the document points that are the closest neighbors to your query point. It's simple, it's fast, and it's incredibly powerful. But is it perfect?
And this is where it gets really interesting, because this beautiful system, where every single idea is just one point in space, well, it has a hidden mathematical limit that researchers are only now starting to fully wrap their heads around.
I mean, this is the million-dollar question. If every document is just one point, and a search result is just a collection of the closest points, can that system really represent every single unique group of documents the user might be looking for? What happens if the documents you need aren't actually neighbors on the map at all?
And here is where you see the sheer, mind-boggling mismatch.